Okay, welcome to Math 196, Spring 2014, video 23, chapter 5.2, and we're going to graph two linear inequalities, or maybe even three, and find the corner points of the regions that result. So in chapter 5.2, problems 5 through 8 are sort of the basic graphing problems, including finding the corner points. Problems 1 through 4, 9 through 12 are about identifying the four regions that a pair of linear inequalities create. And then 13 through 17, 19, 21, graphing linear inequalities in the first quadrant, and then 35 through 39 are word problems. A brief comment before we get going. That is the standard equation for a line. An important point that comes out in the future is if we solve this for y, we get this. Y is c divided by b minus a over bx. An important point to note here, the slope, right, mx plus b, depends only on a and b. Remember that a and b are the coefficients of x and y. In fact, the slope is minus a over b. The slope doesn't depend on this number. This is just involves the y-intercept, right? So we'll see at the very end of this video why that's important. Okay, but before we get there, graphing pairs of inequalities. So this is like problems 5 through 8. Graph the linear inequalities x plus y less than or equal to 12, 9x minus 4y greater than or equal to 36. Find all corner points. Is the region unbounded or bounded? So how do we graph linear inequalities? Well, first we want to deal with the line x plus 2y equals 12. What's its x-intercept? Set y equal to 0, solve for x. So x equals 12 is my x-intercept. And my y-intercept, set x equal to 0, solve for y. 12 divided by 2, that's 6. And I need a test point. If I plug in 0, 0, x equals 0, y equals 0, into this inequality here, what do I get? Well, 0 plus 2 times 0 equals 0, which is less than or equal to 12. That's true, because 0 is less than or equal to 12. And so that means 0, 0 is on the side of this graph that we want to deal with. So, second line, 9x minus 4y equals 36. What's my x-intercept? Again, the x-intercept is this divided by the coefficient of x. It's what you get when you set y equal to 0. 36 to 9 divided by 9 is 4. The y-intercept is y equals 36 divided by minus 4, which is minus 9. Right? And now, is 0, 0 on the correct side or not? So what's our test point? Is 0, 0. If I plug that into this inequality, I get 9 times 0 minus 4 times 0. That equals 0. Is that greater than or less than 36? Well, it's actually less than 36. And so we got something that's inequality is backwards. Rather than getting greater than, I got less than. So that means 0, 0 is on the wrong side. Okay, right side, wrong side, what does that mean? Well, let's sketch this. So we'll put in an x-axis and a y-axis. This line has an x-intercept of 12 and a y-intercept of 6. So we'll put 12 there, 6 there. It's a less than or equals. Right? Both of these are less than or equals, or greater than or equals. But that means I want a solid line. If it was just strictly less than or strictly greater than, I'd get a dashed line. Great, so that's x plus 2y. That line is x plus 2y equals to 12. 0, 0. When I plugged in 0, 0, I got something true. Let's scroll up a little bit. Right? Because 0 is less than or equal to 12. So it means 0, 0 is on the side that I want to shade in. So 0, 0 is here, and so that means I want to shade in this side. Okay, what about the second line? Well, let's go to a red pen for that. X-intercept is 4, that's in here. Y-intercept is -9, that's down here somewhere. And so my line is like that. When I plugged in the test point, I got the wrong inequality. 0 is less than or equal to 36, not 0 is greater than 36. So that means I want the side that 0, 0 is not on. I want to shade in this side. Great. So the black shaded part is the solution to x plus 2y less than or equal to 12. The red shaded part is the solution to 9x minus 4y is greater than or equal to 36. So the region we shaded twice, both black and red, that solves both inequalities. That's the region we are after. That's the solution to this inequality. Is it bounded or unbounded? It's unbounded. Oops. Terrible handwriting there. Why is it unbounded? Well, you can just go off to infinity that way if you wanted. So it's an unbounded region. If you're bounded, right, that means you're stuck. You can't go off to infinity. And the last thing we need to know is find all corner points. What's the corner point? That's the corner point. It's where my two lines crossed. So I think the next page is blank. So let's recreate our little drawing. Right, we have 6 and 12, and that was the line 2x plus x plus 2y equals 12, and then we had intercept of 4 and -9, and that was the line 9x minus 4y equals 36. Okay. And what we want to know is, well, this was the region. We want to know what this corner point is. And so what do we know about a corner point? Corner point is the intersection of the two lines. So the two lines we have are x plus 2y equals 12 and 9x minus 4y equals 36. I need to find out what the point of intersection is, right? I need an x and y that solve both equations at the same time. There's a number of different ways to do that. I usually like to do what's called the process of elimination. So what I'll do is I will multiply the top by 2, and then it makes this 2x plus 4y equals 24, and 9x minus 4y equals 36. And this is why it's called elimination. Now, my coefficients on y are equal and opposite, so if I add these two equations together, the y's will cancel out. So I get 11x, 4 minus 4, that's 0y, equals 50, equals 60. Great. So x equals 60 over 11. Now, that gives me the x-coordinate of my intersection point. That's 60 over 11 here. What I need to know now is what's the y-coordinate of that point. Well, I've got lots of equations floating around. I just need to plug into one of these two equations, to find y. So I'll plug it into this equation. So 60 over 11 plus 2y equals 12. And keep in mind that 11 times 12 is 132. So 12 is 132 divided by 11. So moving the 60 over to the other side, we get 2y equals 132 over 11 minus 60 over 11, which is 72 over 11. And then dividing both sides by 2, right? Coming back over here, we get y equals 36 over 11. And that gives me my corner point. Oops. So, corner point is 60 over 11, comma, 36 over 11. And we do that by elimination, where we try and get the coefficients on one of the variables to either match, and then we can subtract, or get them to be equal and opposite like we did here, and then you can add to eliminate one of the variables. Okay, so example 2, like problems 1 through 4 and 9 through 12, graph the linear inequalities x plus 2y less than or equal to 12, 9x minus 4y greater than or equal to 36, and identify all 4 regions that results. So this is what we just did, right? That's the graph from example 1. So we'll put this back up. We have 6 and 12 as intercepts for one line, and minus 9 and 4 as the intercepts for the other line. So this region here, whoa, what happened there? So we know this is let me just put in our equations. This is the line x plus 2y equals 12. This is the line 9x minus 4y equals 36. This region we know was x plus 2y is less than or equal to 12. 9x minus 4y is greater than or equal to 36. Right? That's what this region is, because that's the problem we just found. So this region, this quadrant, whatever this place is, it corresponds to these two inequalities. What about this region over here? What is those two inequalities? What are the two inequalities that give rise to that region? And one way you can check is just pick a test point. So we'll say inequalities for this region. Well, take your test point, 0, 0, and plug it into your inequalities. So 0 plus 2 times 0, plug into this line, equals 0, and that's less than or equal to 12. So which side of the line x plus 2y equals 12 is 0, 0 on? Well, this must be x plus 2y less than or equal to 12. That's this side, because when we plugged in 0, 0, we got a number less than 0, which is 12. What about the other line? 9x minus 4y equals 36. 9 times 0 minus 4 times 0, that equals 0. This is why 0, 0 is always such a nice test point. Everything turns out to be 0. We know that's less than or equal to 36. So the side that 0, 0 is on, that must be the less than side of 36. So if you've got a region, you can always test what the inequalities are by plugging in a test point from the region into both, and that'll tell you what the inequalities are. The other thing to keep in mind is when you cross a line, the inequalities should change from less than to greater, or greater than to less than. So if we go from x plus 2y equals 12, this side is the less than side, this side then must be the greater than side. So the inequalities for this region up here must be x plus 2y is greater than or equal to 12, and 9x minus 4y is less than or equal to 36. And then if we cross going from here to here, right, we're crossing the line 9x minus 4y equals 36, so this inequality should switch from less than to greater than on this side. And then if we went back here, this should switch from less than to greater than again, which is what we, from greater than to less than, which is what we got there. So, two lines separate the plane into four regions, right? And if you look at your inequalities, you could have a greater than and greater than, less than, greater than, less than, greater than. You know, and you can figure out, if you can figure out one quadrant, you can figure out all of them. You can always figure out a quadrant by plugging in a test point. Okay, good. Okay, so graphing with non-negative restrictions. Here's another problem. Find the solution of the following inequalities by graphing. Find all corner points of the solution region. Is the solution region bounded or unbounded? And here we have 1, 2, 3, 4, 5 inequalities, but we know these last two just mean in the first quadrant, so only x is greater than or equal to 0. So we'll call this one line 1, this one inequality 2, and this one inequality 3. Now we know pretty quickly how to handle inequalities. So for inequality 1, x-intercept, 20 divided by 2 is 10, y-intercept, y equals 20, test point 0, 0. If I plug in 0, I get 2 times 0 plus 0, which equals 0, which is actually less than or equal to 20, not greater than or equal to 20, so I want, that makes me sad, other side, so this is on the wrong side when I get around to graphing it. Line 2, x-intercept, well this is easy because there's no coefficients, x-intercept is just 15, y-intercept is 15. If you plug in 0, 0, gives me 0 plus 0 is less than or equal to 15. That's true. So 0, 0 is on right side, the correct side, the side that we want. And then 3, what's my x-intercept? X equals 20. What's my y-intercept? Again, you go to here, you set x equals 0, that gives you y equals 20 divided by 10, which is 2. 0, 0 is my test point. When I plug that in, do I get something less than 20? 0 plus 10 times 0 equals 0, which is in fact less than 20. So 0, 0 is on the right side of that line. Great. So what does my inequalities look like? Well, we're only interested in the first quadrant because that's the x greater than or equal to 0, y greater than or equal to 0. X-intercept of 10, y-intercept of 20. So we'll put the y-intercept of 20 up here. That makes the x-intercept 10 there. And it's often useful to write the equation of your lines. So this is 2x plus y equals 20. If we put 15 here, and then that'll be 15. And this line is x plus y equals 15. And then the last line has a y-intercept of 2 and an x-intercept of 20. Of course, it's always easier to draw the line first and then put in the intercept. And this line here is x plus 10y equals 20. Great. And of course, which side do we want? For this line, we wanted the side that 0, 0 is not on, right? And so that means we want that side. So that side of this line. I suppose I should have done this in multiple colors. That would have been easier. So if we make this one a red line instead of a black line, Which side of that do we want? Well, we want the side 0, 0 is on, so that's this part. And then we'll make this one a blue line. And what side of that line do we want? We want the side that 0, 0 is on. So we shade in this side. So what's the region that got shaded by all three? That's the region we're after. And that's this region. Right. It's on the greater than side of the black line, it's on the less than side of the red line, and it's on the less than side of the blue line. And so that's the region we're looking for. What are our corner points? Let's go back to a black pen real quick. Well, there's 4 corner points. One there, one there, one there, and one there. And we will call this A, B, C, and D. We want to be able to find these 4 corner points. Okay, so let's draw this picture a little bit tidier now. Put an x-axis and a y-axis. And again, we had 20 and 10 as my y-intercept and x-intercept of the line 2x plus y equals 20. And then we had 15 and 15 as the x and y-intercept of the line x plus y equals 15. And then finally we had 2 and 20 as the x and y-intercepts of the line x plus 10y equals 20. And the region that we're interested in was, I wonder if I have a color that's not any of those colors. We could shade it in green, I guess. We're interested in this region here, the green region. Okay. We'll call this corner point A, this corner point B, this corner point C, this corner point D. We note A, well, we know what that is. That's the point 10, 0. And D, we know that. That's got x coordinate 15, y coordinate 0, so that's those 2 points. B is the intersection of the blue line and the black line, right? 2x plus y equals 10, and x plus 10y equals 20. And what's C is the intersection of the red line and the blue line, and that's going to be x plus 10y equals 20 and x plus y equals 15. So we need to solve these equations for x and y to get the coordinates of B. We need to solve these equations for x and y to get the coordinates of the corner point C. So to find the corner points of B, what do we have? Well, it's the intersection of 2x plus y equals 20 and x plus 10y equals 2. So what I want to do is match coefficients. So what I'll do is multiply this one by 2. And so these two equations become, keep the top one, 2x plus y equals 20, multiply the bottom by 2x plus 20y equals 4. Great. So, oh, it's not x plus 10y equals 2, is it? It's x plus 10y equals 20. So this becomes 40. So I'll subtract the top from the bottom. 2x minus 2x is 0x. Subtract top from bottom. 2x minus 2x is 0x. 20y minus y is 19y. 40 minus 20 is 20. So y equals 20 over 19. Great. So what's x? I'll plug y into the equation. Well, x plus 10y equals 20. So x plus 10 times y is 200 over 19. 20 is 380 over 19. So x equals 380 minus 200, 180 over 19. Great. So what's b? Well, we'll do that in a second. How do we find c? Well, same deal. We want to find the intersection of these two lines. X plus 10y equals 20. And x plus y equals 15. Now, fortunately, coefficients on x already line up, so we can just subtract bottom from top. X minus x is 0, 10y minus y is 9y, 20 minus 15 equals 5, y equals 5 over 9. We can plug that right into there, into that second equation. Now we can plug this into x plus y equals 15. So x plus, now we plug in our 5/9 in for y, equals 15. Equals 15. But 15 is 135. Don't know what all that was. 135 over 9. So x equals 135 minus 5, 130 over 9. Excellent. So we can make a little table if I have just a little bit more space here. What are my corner points? A, B, C, D. And what are the coordinates? Well, A, as we know, was 10, 0. B, as we calculated, had x equals 180 over 19. And y is 20 over 19. C had y equal to 5/9 and x equal to 130 over 9. And D, as we found out above, we'll keep going, there we go, 15, 0. Okay, so 4 corner points, 2 were x-intercepts, those were easy to find. B is the intersection of a line with another line, and so you have to eliminate one of the variables. Here we multiplied the bottom line by 2, so we can eliminate the x variable, solve for y and plug it in. C, likewise, is the intersection of this line and this line. So coefficients already lined up, so you can subtract the bottom from the top to eliminate the x's and solve for y, and then you plug that back in and you can find out what the coefficients are. Great, so now we know how to find a region and the corner points of that region. Suppose we're faced with a word problem. And this is, Bob is a furniture maker. He makes tables and chairs. Each table takes 4 hours to assemble, 1 hour to paint. Each chair takes 1 hour to assemble and 1 hour to paint. He has 200 labor hours available each day for assembly. And he has 100 labor hours available each day for painting. So what are the inequalities and what are the feasibility regions? And find out corner points. Okay, so we'll start with a table. Tables and chairs. What goes into our table? And totals. So what's our variables? Anytime you do one of these word problems, you have to have variables. Anytime you do anything in math, you need variables. So tables and chairs. I suppose you could call them T and C, but X and Y. Okay, so how much time does it take to assemble? You're making X tables. Each one takes 4 hours, so 4 times X, that's how long it takes to assemble X tables. If you made 10 tables, it would take you 40 hours to assemble it. 1 hour to paint, so 1 times Y. If you're making 10 chairs, sorry about that, paint, that's the next row. 1 times Y. If you're making 10 tables, it would take you 10 hours to paint, 1 hour for each table. Likewise for chairs, where's my chairs? 1 hour to paint. Each chair takes 1 hour to assemble, so 1 times X, 1 times Y, sorry about that, and 1 hour to paint, 1 times Y. Okay, 200 labor hours available each day for assembly. What does that mean? Well, you can't go over 200, right? So when we're thinking about this budget here, you have enough people so that you can spend 200 hours a day assembling things, but you can't do more than that because you just don't have enough people. So the hours for assembly has to be less than or equal to 200. Likewise, the hours for painting has to be less than 100. Great. So we can just truncate this table a little bit like that. So what are my inequalities? I have an assembly budget. 4x plus y has to be less than or equal to 200. And I have a painting budget. Painting budget. Y, oh, this is supposed to be an x. X plus y less than or equal to 100. Okay, and non-negative restrictions. We're making tables and chairs. You can't make negative tables. You can't make negative chairs. And so x has to be greater than or equal to 0. Y has to be greater than or equal to 0. We are living in the first quadrant. Great. So for assembly, we'll just call this 1 so I don't have to write assembly a billion times. And we'll call that 2 so I don't have to write painting a lot. So for equation 1, usual deal, x-intercept 200 divided by 4. 50. Y-intercept is y equals 200. If you plug in 0, 0, my test point, you get 4 times 0 plus 0, which is less than or equal to 200. That's good. 0, 0 is on the correct side. Assembly budget, what's my x-intercept? Well, x equals 100. That's easy to do. My y-intercept is also y equals 100, because if you set x equal to 0, solve for y, you get y equals 100. And my test point 0, 0. If I plug 0, 0 into this, what do I get? I get 0 plus 0. And that is, in fact, less than 100. Great. So we want the side that 0, 0 is on for both of them. And so now we can sketch this graph real quick. Just the first quadrant. Tables, that's my x chairs, that's my y. And we have an x-intercept of 50 and a y-intercept of 200. So there's 200 and 50. And this is my assembly budget. And we want this side of the assembly budget, and only in the first quadrant. So this is under budget, this is exactly on budget, this is over budget. Every point in the plane corresponds to a certain number of tables and chairs. Any combination out here in tables and chairs would just take too long to assemble. Those are non-feasible, these are feasible. So what about my painting budget? Well, the painting budget has an intercept of y-intercept of 100 and an x-intercept of 100. And we want the side 0, 0s on. Great. And so this is the painting budget. So what's going on here? If I think of any point in the plane, we'll go back to my black pen. Like I said, suppose we pick the point 100, 100, which would be around here. right? It's on the wrong side of both lines, right? That should be over budget for both of my assemblies. So for this, the assembly would take me 400 plus 100 equals 500 hours, because 100 tables would take me 4 times 100, which is 400 hours, plus 100 chairs, that's another 100. So on the wrong side of the assembly line, way over budget. And painting, right, would be 100 hours plus for tables, plus another 100 hours for chairs. That's 200. Still also way over budget. So this is just, you can't make this many because you just don't have the time. So this region here is called the feasibility region, because every point in here, right, if you think of it as a number of tables and a number of chairs, every point in there is within both of your budgets. It's something that's feasible for you to do. So we can tidy up this picture a little bit. Am I running out of space? Yes, I am. That's sad. So let's tidy up this picture a little bit. Well, we'll tidy up the picture on the next one. What is this corner point? Right? We can find all the other corner points. There's one there, and one there, and one there. Right? This is obvious, 0, 0. This is the y-intercept of the red line. That's not too hard to find. This is the x-intercept of the black line. That's not too hard to find. This is the intersection. So that corner point is the intersection of my two lines. And what are my two lines? 4x plus y equals 200. X plus y equals 100. Not too hard to find the intersection point. We can just subtract the bottom from the top. The second equation from the first. 4x minus x is 3x. Y minus y is 0. 200 minus 100 is 100. So x equals 100 over 3. If you plug that back into this equation here, into x plus y equals 100, you can find that y equals 200 over 3. Because when you add those together, you get 300 over 3, which is equal to 100. So that tells me what that corner point is. Great, so we found all the corner points. Okay, so now on this next page, we have an additional problem. And before I go through that, let me redraw this picture, this slightly less messily. So great. So we have 250 as my intercepts for my assembly budget. And then we had 100 and 100 as the intercepts for my painting budget. And then we had 4 corner points. There, there, and there. We'll call this A, B, C, D. The region that I'm interested in is this one. So what are my corner points? Make a little list. And they're x and y coordinates. A, B, C, D. Corner point A was 0, 0. Corner point B is 0, 100, because that's this y-intercept. Corner point C, we found out above, was 100 over 3, 200 over 3. And corner point D is 50, 0. And let's just remember that this is my table axis, this is my chair axis. Okay, great. So there's a tidied up picture from the previous thing. So Bob, same problem as before. But suppose he gets $6 profit on each table, sells chairs for $3 profit on each chair. So what is the profit 3 equals $300 line. What is the profit equals $600 line? This should be to the graph in example 4. So let's switch to a red pen for a moment. Profit we'll call it P. Oh, it's a good letter for profit. $6 for each table, so 6x if he's selling, and $3 for each chair, X number of tables, Y number of chairs. So if P equals 300, right, $300 profit, that means he must be selling combinations of chairs and tables that satisfy this equation. 6 times the number of tables plus 3 times the number of chairs equals 300. We can simplify that a little bit. Divide everything through by 3. Oh, great. Well, this is an easy line to deal with, right? X-intercept is X equals 50. Y-intercept is Y equals 100. Oh, so that's actually the line that starts at this corner point and runs through that. So this is my profit equals 300 line. Now, the nice thing to remember about lines is every line has a less than side and a greater than side. If you sell no tables and chairs, your profit is 0. So 0, 0 is on the less than side. So this side of the profit line is profit less than 300. This side out here, right, that side, this is the profit greater than 300. And this line itself, this is where he's making exactly $300. So if he sells 50 tables and no chairs, well, 6 times 50 is 300. If he sells 100 chairs but no tables, 3 times 100 is 300. But no, there is part of the feasibility region, this part, where the profit is greater than 300. Right? He can actually make more than $300 if he picked a combination of tables and chairs that lands up in that part of the feasibility region. Okay, what about this profit equals 600 line? So let's go to blue for that one. If P equals 600, what does that mean? Well, he's selling combinations of tables and chairs that satisfy this equation. 6 times the number of tables plus 3 times the number of chairs is $600. And again, we can divide everything by 3 to get 200 equals 2x plus y. And the x-intercept, x is 100. Right, 200 divided by 2. My y-intercept is y equals 200. Great. So y equals 200, x equals 100. That's actually the intercepts for these other two lines. That just happened because of the numbers I picked. It doesn't always happen. So there's my profit equals 600 line. What do we know about profit equals 600? Well, one side, that's out here, is profit greater than 600. The other side, the side on this side, is profit less than 600. Can he make $600 in profit? Well, no. These are the only combinations of tables and chairs that he can make. That's only in here. So he can't actually make $600. But an important thing to note about your profit lines, and we'll go to a green pen here because I've used so many colors. What the heck? If we think back to the thing we did at the beginning, these have the same slope, right? The slopes are -2, right? Minus A over B. What does it mean if they have the same slope? They're parallel, right? So the red line, which is the profit equals 300 line, and the blue line are parallel. In fact, all the profit lines are parallel because they all have the same slope. changing the profit only means changing this number, right? But not changing either of the coefficients, so they're all going to be parallel. So what do the profit lines look like? Well, whatever profit line you pick, say like this one, it would have to be parallel to the red line and the blue line. This is in between the profit equals 300 and the profit equals 600, so that's going to be, this green line will be profit between 300 and 600. Right? This line, you can't reach that profit because it's not in the feasibility region, but you could have a profit here, right? And that profit line would have profit greater than 300. So where's the maximum profit going to be? Well, if you look at the profit line that touches that last corner point, right? That's a feasible solution, right? You can do the corner point. This line doesn't touch the feasible region anywhere else, so that's sort of, you can't get that much profit at any other point in here. And if you go a little bit further, right, you leave the feasibility region entirely and you won't be able to make any profit at all. So for this one, so at the point 100 over 3, 200 over 3, you get your maximum profit. And what's your maximum profit? It is 6, right, times 100 over 3 plus 3 times 200 over 3. Right, and this will be 200, this will be 200, so 400. That'll be your maximum profit. So this line here, that gives you the maximum profit. That's your P equals 400 line. It's between 300 and 600. So, an important point there, which we'll see more of in 5.3, because all the profit lines are parallel, right? If we start with a profit line that crosses through the feasibility region, we keep raising the profit. Eventually we get to the point where the profit line just leaves the feasibility region by touching one of the corners.